So let's look at an example of how we can use a direct comparison test. So I want to know if this series here converges or diverges. And this is going to be the form that most of the problems that you're going to have to do will take. So we have this series x to the n over n factorial squared. And we want to know if that series is going to converge or diverge. This is not a series that we are familiar with. So if we were to write out the first few terms, and so we've written out the first few terms, and this is not a series that we are familiar with. We've not worked with this. Although we have worked with a series that's pretty similar to that. Anybody know what it is? So this series here is a series that we have dealt with. What is this series, this Taylor polynomial representing? What function? That is the e to the x Taylor polynomial. And what is the radius of convergence for this? Does this series converge or diverge, or is it conditional on the x value? The e to the x series, converges for all x values. Doesn't matter what x value we put in. If we have enough terms, this is going to be essentially the same as this within some threshold of accuracy. And if we add infinitely many terms, they're going to be equal. So this is going to converge for all x values. So this right here is a series that we know converges, and it's very similar to the series that we have in question here. We want to know if this series is going to converge or diverge. What we're going to do here is we're going to compare the nth term. So rather than using one of the specific terms, I'm going to compare this term right here, the x to the n over n factorial squared, to the nth term in the e to the x series, which is x to the n over n factorial. Okay, so I want to compare those to each other. So how do these two series compare? The numerators are going to be the same, right? So for each term, the numerator is going to be the same. How does the denominator in my series in question compare to the denominator in the series that I know? The denominator is larger here. So when the numerator is the same and the denominator is larger, how are the two terms going to compare? Which one's going to be bigger? The blue one's going to be bigger, right? So since the denominator here is bigger, we're dividing by a bigger number, we're going to end up with a smaller number. So every term in this red series is going to be less than every term in this blue series. Well, we know that the terms in these blue series are going to add up to some finite limit. So what does that mean about the terms in the red series? It's going to converge. So term by term, every term in this red series is smaller than every term in a series that we already know converges. Then we know that this series itself is also going to converge.